Hello everyone, welcome to another Watch Me Do Math video. In this video I'm going to be talking about IB chemistry, in particular IB higher level chemistry. And the reason I'm going to be talking about this is that a friend and also a viewer was talking to me about this subject the other day and mentioned that it is quite a difficult subject to get an intuitive grasp on, despite the fact that it is a fairly base level natural science. Not as base level as something like physics, but more base level than something like biology, where base level means more fundamental in the sense that a more base level subject can explain some phenomena in the less base level subject. So, this idea goes on to make a sort of a pretty interesting conclusion about the way you should be spending your time studying IB chemistry. So I'm going to pause the video and draw out some topics here. Boom. Okay, so these are basically the topics that you experience in IB chemistry, the topics that you need to learn about. And if you're familiar with the subject, then I won't need to explain what these are, but I'll go through the most essential ones anyway. So you can see that I've boxed some of them off in a solid line and some of them in a dotted line. The 7 topics boxed off in the solid line are some of the most important to understand in order to be able to easily study the rest of the syllabus. My advice to you is that you spend at least half your time or more into understanding these 7 topics as perfectly as possible, because the rest of the topics in IB chemistry, except for perhaps 6 and 16, which are a field of study in their own and have a dotted line around them because I would consider them sort of semi-essential. Those topics are the fundamental principles that can be used to understand the rest of the topics in the course. So if you have a really good understanding of the ideas involving electron configuration, electron orbitals, periodic trends, stability, molecular structure, bonding geometry, and sort of all the thermochemistry that underlies why things happen, then you will have a much easier time understanding the rest of the syllabus, basically. Because the reason I say this is because 2, 3, 4, 5, 12, 14, and 15 are all a kind of physics. And perhaps there is a bit of bias here because I myself am interested in physics. I applied for physics degrees this cycle because I'm in year 13. But the reason that I think these topics are so important is because they are useful in understanding everything else in the course. Obviously, 1 is somewhat important as well to this, but part of 1 is a kind of analysis, and a lot of it is fairly obvious to people after they have covered the rest of the course, because it's something that blends in very naturally with all the other topics, but is not as fundamental to understand all the other topics. So these 7 topics that I highlight here should be the focus of a lot of your time, and you should try to understand the other topics in the context of these 7. Now firstly, why haven't I included 13? Well, because 13 is mostly focused on a particular element of 3, that is the understanding the D block transition, the first row of D block elements, those transition metals, and their ligands and complex ions and so on. That is actually not as, the important information there is all contained in other areas of the syllabus, as in my opinion, in my experience, topic 13 is more of an application of 12 and 14 and so on, rather than it itself being a important thing to understand. and I may even go as far as to say that that might be the case for 3, but I would still say that 3 is fairly fundamental to the course. So these early topics, I reiterate, are incredibly important to understand the rest of the course. Because I would split it into this, and then the sort of the everything else group, where firstly, 7, equilibrium, it is an application of 6 or 16, 5 or 15, and 1, because you study how concentration affects basically the probability of 2 molecules being in the same place and colliding, and so on and so forth. So this is fairly clearly an application of other stuff you learn, such as the Gibbs free energy idea from topic 16. And what about 8 and 18? Well, this is, like, 8 and 18 is kind of another application topic, because what you're doing is studying the properties of things that are already there. It's like acids and bases are these sort of creatures that you need to deal with. And the understanding that you can get in 8 and 18 is limited by how good your understanding is in basically all of the other topics, 2, 3, 4, 5, 12, 14, 15. 9 and 19, redox reactions, are especially limited by your understanding of 5 and 15, as well somewhat of 8 and 18, and then 10 and 20, organic chemistry. Like, your understanding here is not necessarily limited by so much, but I would say that this is a subject that it is very important to know 2 and 12, 4 and 14, and 5 and 15. And then this is sort of off on its own and uses all of the other elements of the course. So basically, if you, like, of course it's very possible to know the later topics without having perfectly understood the earlier topics, but it is more difficult because you will be memorizing and not understanding. Of course, there is an element of memorization involved in those topics anyway when you study them, because they are application-based topics. However, that is unavoidable, and what you should be trying to avoid is memorizing where not necessary, because it's something that you could intuitively learn through an understanding of the earlier topics. Because IB chemistry builds on itself to complete a whole picture of chemistry that you're going to be dealing with in your head. Topics are, questions are never on sort of one topic alone, unless they're very simple. And for that reason, you want to have a good understanding of the whole course, which, as I say, is going to originate from a solid understanding of 2, 3, 4, 5, 12, 14, and 15. So now that I've said that message probably like 5 to 10 times in this video already, I want to talk a little bit about how you can gain a further understanding of these topics. So the first thing that I would say is to think about everything in terms of electron density, stability, like charges attracting, opposite charges repelling, and electronegativity. Basically, if you can reduce everything to visualizing sort of the way the particles interact in your head and the way the probability clouds of electrons shift as they are attracted and repelled by electrostatic forces, then this 3D visualization ability that you can develop in your head will be an incredibly useful tool for understanding the rest of the chemistry that you're dealing with. Like, for instance, there's this incredibly good video about hybridization. I'm not 100% sure about remembering who it's by, but I will put a link to it in the description. It was incredibly beneficial to my understanding of topic 14, and everything just clicked with me because he was talking about hybridization in a very fundamental way. He was talking about it primarily from the context of the electron orbitals you learn to deal with in 2 and 12. And for that reason, I think 2 and 12 is like, okay, I'm kind of tripping on my own words here, but the point is it was much easier to understand because he did it from first principles. And it is much more difficult to do the later topics, to do the earlier topics after the later topics than vice versa, because the later topics rely heavily on a perfect or near perfect understanding of the earlier topics. Okay, I cut myself off there because I was just rambling. So the tips I'm going to give you for understanding the earlier topics better are similar to the tips that I'm put forward in my video advice on improving at maths and physics, because the same tips apply to chemistry as well. And to summarize, they are: don't waste time on solving problems that you already know how to solve, because you gain the most by doing the most cognitively demanding stuff. And secondly, you are not sure that you have understood something unless you can explain it to someone who's never learned about it before. If you have a pet GCSE student, or a younger baby brother or dog or stuffed toy that you can talk to and pretend to teach certain aspects of IB chemistry to, then you're going to have a better time understanding it, because as you work through the explanations, you will notice all of the points where your brain fails, and you will notice all of those sort of weak points that you need to fix up by filling in with knowledge and understanding from the resources around you. And that's the way you can sort of build this near-perfect structure of knowledge in your head, by exposing all the weak points, by trying to explain. And to an extent, that's something that putting explanations on the internet helps with, because you know that for other people to be interested in your explanations, they need to be thorough, developed, and coming from a place of understanding. If at any point you find yourself stumbling in those explanations, then, again, I say, consult the resources around you and try to sit down, think about, and understand the parts that you are unable to explain. Do not gloss over them. Do not go, oh, I'll deal with this later, because that is the most dangerous thing you can do when you are trying to understand a subject. Sciences and maths usually build on themselves, and the most important thing is to know them intimately as you move through the course in order to maintain a high standard of academic performance. So that's all I have to say on this topic for the time being. In summary, first few topics of IB chemistry are more fundamental than the rest. Try and understand them by explaining them to other people and ignoring the problems that you already know how to solve. I would love to hear your stories and thoughts on this video, and you can email those to watchmedomath@gmail.com. if you have any questions or suggestions for future videos. Until then, thank you for watching.